driving, how automatic driving is set up, what automations there are, what sensors we are using to record information from outside the vehicle, and then I will finish my presentation with some machine learning approaches in automated driving, which is also the field that we are working together on. So let me start with the vision of automated driving. Of course, the idea of autonomous driving has been so old as basically the car itself. So the word automobile kind of comes from self-moving. So automobile means, it's an old Greek word for self-moving vehicle. Of course, the first real car was not automated, but this was the idea. You don't have horses anymore or anything moving the vehicle. The vehicle is moving by itself. And then from 1888, where Bertha Benz, the wife of the founder of Mercedes-Benz, did the first test drive with what you would call a car, I guess. It does look different than today's cars, but it was the first car. From that, it was still a couple of years before people started to think about automated driving. If we look in the 1950s, there were some pictures drawn by a guy named Arthur Radevor, which is where he was basically drawing some futuristic ideas on how the future could look like. He was thinking of like gigantic corn and stuff like this, but also on more, well, today we would say more realistic stuff, such as automated driving. You can see the people in here, well, they have the same vision that we have today from automated driving. So they are playing cards, having a drink, watching TV. So all the stuff that you can't do, or you shouldn't do when you are driving a car, you can do in an automated car. By the way, if I'm speaking too fast, please interrupt me and ask me to explain a bit slower. There are some advantages for this system that we don't have in today's traffic. Can you think of why this would be an easy application for automated driving? What makes this picture, well, easier than today's traffic? Any ideas?
Clear track.
Yes.
And then no, like everyone is just working in one direction.
Exactly. You have the markings for the vehicle to follow. You have this in factories today. Robots in factories drive on these markings. And you have lifted tracks. So in Taiwan, you have many highways that are lifted. We don't have that in Germany. All our highways are flat, almost like 99% are flat. Lifted highways makes it easier to do automated driving because you have something that we call a separated operational design domain. So you don't have to share traffic with animals, bicyclists, pedestrians. This is also the reason why automated driving on highways is relatively advanced today. But in cities we are not so far because this comparatively is easier. So this is not a history lesson, this is an engineering lesson, but I want to give you a small history on automated driving. So it started, I'm sorry this is very small.
So if I and then I do erosion, and then I can reverse this one, and then I can easily get the outline. Okay, so that's the image, and then you can get an outline depending on you use 4-neighbor system or 8-neighbor system. You can get different results. 8-neighbor, you will see single line because you also have the corner part. 你四个角都有上去嘛，所以它看两条线比较粗一点。Okay, so that you have many different patterns you can apply. For example, we can apply your structure element like this. Say, I want to add this pattern, or I want to match this pattern. Check if there is such pattern. So you have this one, and you can apply. Okay. And this is other rules. Maybe if you are working in TSMC or something, and then you have to check if there are some noisy or defects, and then you, maybe the defect have certain type of shape. Okay. And multi-head attention. So because right now, Danny is working on transformer, and Ting is not working on transformer. No? No? Okay. So there are many transformer material you can have a look. But probably you will need to write down the equation for this one as well. So we have some equation and information of this one as well. Okay. I will go through I think you can read this by yourself because basically you are already doing this one. Okay. Yeah. So you have position encoding and talk about this one. Right now you have 6 or 8 range, 8 category. Maybe you split into only 3, and then you can show, okay, for each category it does contain all this. And this also can show bigger numbers in each category. Okay, so you want to show this one? Yeah. And about the page 6 and 5, why do you split into plural anxieties instead of positive negative? In this one, it's about cancer origin, not malignancy. No. This data is about origin.
I think it's about origin.
Oh, okay.
So all the data
High. But of course, we can use positive and negative to show. So we try to use different ways to show, but maybe we can use another data. So yeah, so we just try to show how many ways to show this data.
So if I look at this chart, it will mean, this is number only, right? No percentage. Are you able to show?
And this project was supervised by Professor Chuman. And this demonstration introduced the use of point method for image processing on grayscale images, and the application of erosion and direction for diamond and circular tunnels. The aim was to analyze how different interior shapes affect the biological outcomes. And before we dive into the method, here is a brief overview of the experimental setup used for all processing tests in the project. And the CPU is Intel Core i7-8700, and memory is used 16 gigabytes. And I forgot reading the GPU. And this specification provides sufficient performance for both the image processing and the morphological operations implemented in Python. And for libraries, the script begins by encoding the required library CV2 is OpenCV and is used for image processing. NumPy is for array and NumPy is for array and matrix operations. And time is input to measure how long the erosion and direction test. And this line defines by diamond shapes and kernel using the NumPy array. And the value 1 or 2 indicates that this pixel is part of the structuring element. The diamond shape is centered and symmetric, as this.
它这边是用物联，
And load image and the initial output. And the grayscale image is loaded from the specific place using OpenCV. And the height and width of the image are extracted and stored in the HMW. And we copy of the input image is created and stored in output. And the current time is recorded before the morphological process begins. Two nested loops go through each pixel of the image, skipping 2 pixel border to avoid the index out of bounds error when extracting the 5x5 piece page. 5x5 page center at pixel I2 and is extracted from the image within the diamond shapes region of the patch. The minimum pixel value is found, and this minimum value is assigned to the same pixel position in the output image.
25.
So hi everyone, and our supervisor is Professor Dr. Chun Wang, and we are going to discuss the journal paper published in medical analysis. So the title of this paper is HMIL, Revisiting the Attention-Based Macro-Instance Learning for Foresight Pathological Image Classification from the Perspective of Instant Questions. And we will talk about why we chose this paper, introduction, related work, methods, result, conclusion, and discussion, pros and cons, and how this paper helps our research. And so first is why we chose this paper. So there are 4 reasons why we chose this paper. So HMIL reformulate the traditional attention-based ML plan introducing the class-specific scoring. And the second is the strong methodological contribution. So we propose the RAC, the local spatial constraint, and SAC, the constructive learning inside the framework of the design. And the third is the state of the art. It's also they compare a lot of different data sets results, so we will report in the sections. And so the fourth is the design aligned with the real clinical needs. But I think the clinical need in this paper is not as much as our research, because the important part in this paper is about their methods. So, and the last one is really relates to our research, so we can try to rethink the structure and the idea to improve our framework.
So if you have any questions, you can ask. Okay, you can just raise your hand. Okay, just in case the presentation is very fast.
Okay, and well, next is introduction. So first we talk about the research background, And the traditional pathological diagnosis relies on the pathologist using the microscope to examine the stent tissue slice. And with the rise of the whole slide imaging and the gigapixel digital slide has become the new standard. So this WSI presents a new challenge is that the large image size and lack of page level annotation makes supervised learning is difficult. So the multiple instance learning is what we adapt for weekly supervised WSI analysis. So in ML, each WSI is treated as a bag composed of many unlabeled instances, which we can say the pages. And generally the foundation of the ML, the appartive bag means at least one page is appartive, a negative bag means all pages are negative. So the model must classify bags and discriminate the instance. And the limitation of existing attention-based ML is unreliable attention scores. So the attention scores are jointly determined by both the attention module and the bag classification head. Thus, the scores do not accurately reflect the instance level logical attributes.
7 is very useful, okay, for everyone. 27 is just they have the input view type, and then with this feature encoder, they encode the feature, and then they call it embeddings. So that's their encoder outputs, and they have this outputs. Okay, and this output can be used for like cancer detection, cancer subtyping, or tissue agnostic cancer subtyping, or further biomarker prediction. That's what we are doing now. Right now, for example, we are using UNI, and then UNI can be used for certain cancer subtyping or certain biomarker prediction, like EGFR is biomarker prediction, or subtyping maybe like cancer detection is like malignancy detection. Subtyping can be say cancer origin, like different subtypes, or like maybe different lung cancer or different cancer type. So this feature recognition can be further used for different kind of applications. I think that's the meaning of this one. Okay, and then beforehand, of course, they have to create their own classification framework. They are saying the virtual can encode something that's very meaningful, and then if we go to 2022, you will see it can be meaningful, but it's not supervised learning. It just generates 3 kinds of features, but because we haven't used virtual yet. But if you can automatically generate 3 kinds of features, and then those 3 kinds of features can correlate to certain tissue structure, and that's meaningful for the applications, then you'll be very useful. We don't necessarily need to know this component 1, this first embedding, second embedding must correlate to tumor, or this second embedding must correlate to, they have different kinds of meaning, right? But with this kind of embedding system, when we further send to certain kind of pattern recognition models, they will be easily use those embedding to build models, because they already help the model to categorize which features belong to this. So they kind of structure the features. But if they really do that, I think that will be very, very useful. Does this reply to Dan's questions? This is very useful because we are going to write a large AI proposal. This will be very useful. Please also include this